Okie dokie. Hello, Internet. Welcome back to the Ethernaut series. So we're on challenge not coin, and you may ask yourself, Dylan, what happened to all the check marks? We were making progress together, and you were feeling good about all those little check marks that were here. Well, don't clear your cache. If you clear your cache and your data, which I was troubleshooting something separate, completely separate from blockchain stuff, when you clear your cache and all that stuff, it unchecks all your boxes. So, lesson learned, don't do that. Anyways, we're at not coin. And with this challenge, I did cheat. I had to cheat a little bit, but that's all right because we learned a lot as per usual, like all the other times we've cheated. And with this challenge, it's called not coin. So first things first is we're going to read the challenge. So not coin is an ERC20 token. You're already holding all of them. The catch is that you'll only be able to transfer them after 10-year lock period. Can you figure out how to get them out of another address so that you can transfer them freely? Complete this level by getting your token balance to 0. So in reading through this, my initial thought process, ooh, what is this? Uh-oh. Looks like I was playing with some stuff I shouldn't have played with. Okay, all right. We're back in action. I was playing with the tablet. Don't play with the tablet. You played with the tablet earlier. You messed everything up for the video. Anyways, all right, cool. So what I wanted to say for this challenge, as we wrote through the explanation, the thing that I initially researched and looked into was the lockout period. Because I know that I've come across historical videos that talk through how to avoid the lockout period on certain contracts. It's kind of a vulnerability or a flaw in some of the contracts, but after researching and reading about 4 or 5 different types of attacks to avoid the lockout period, none of these actually aligned with this challenge. They're interesting to learn about, but unrelated. So after that, I looked at the links that they provided. So they mentioned that some of these might help, so I probably should have looked at this first, was reading into the ERC20 specs and the Open Zeppelin implementation of ERC20. There's also a consensus version as well, but we'll look at both of these. And when looking at that, you'll see that there's a discrepancy between what's mentioned in the ERC20 specs and what's provided in this contract. And that's somewhat of a hint at how we're going to solve this challenge. So let's go to our notes per usual. Let's go to the top of our notes. And you can see this challenge is really all about ERC20 and specifically how ERC20 can be implemented incorrectly. And if it's inherited and implemented incorrectly, then there is sometimes an opportunity for attackers to exploit any access controls or different types of permissions you put inside of your contract. And yes, I did cheat, and I cheated from our good old friend at this YouTube channel. So he basically helped walk through specifically how to solve this challenge and gave a lot of really good insights, so watch this video if you'd like. In addition to that, another explanation that was slightly underwhelming because usually ZeroX Sage does a pretty good job at explaining a lot of what's happening behind each of these challenges. But this time, not so much. It was somewhat insightful, but yeah, quite short and too quickly to the point. So those are the 2 explanations that I used for this challenge, and then there's a whole bunch of other links I'll walk you through, specifically talking through different aspects of the contract of what we're going to exploit and things that I had questions around that I wanted to learn more about. So before we go into the notes, we'll review our code. So as per usual, I've copied and pasted this into VS Code, just so it's a little bigger and easier for me to draw around. So as per usual, we'll start here. At the very top of our target that we're going to target is our compiler version. So we have that it's .6, but we're going to change this to .8 when we put it in Remix. Floating point is not necessarily a good thing, especially in production. You want that to be stuck at a certain version of compiler. In addition to that, we're going to have our import statement. So this import statement is referring to the ERC20 implementation that we're going to inherit. So we can actually have a token that's based on ERC20. So we're going to use ERC20 as our baseline. And then on top of that, we're going to create our not coin. So here we can see that our contract is not coin, and it's inheriting the methods and all the stuff inside of ERC20 to then utilize in our own contract. Below that, we have some comments. So these comments are basically helping us understand what's happening down here in the constructor. But in reality, interestingly enough, this comment is actually outdated. I'm not sure the creators of this, and I've added this here so you can ignore that, but I'm not sure who the creators of this challenge are, but I guess they probably provide this to give insight to what this decimal item means, but in the end, it's not necessarily necessary here. These two here I'll talk about in a second, but we'll move on to the actual variables that are being established here. So this first state variable is going to be our time lock, and our time lock is going to be, instead of now, this is going to be block.timestamp. So you'll see when you try to compile this in Remix, it's going to give you an error, and it's going to ask you to put this in there instead. And we can see there's another now down here, so I'll replace that while we're doing this. Cool. All right. And really what block.timestamp is doing is basically saying, right now, this current time, and I want you to add this number to it. And that's going to give us 10 years, because we're going to take 365 days times it by 10 from this moment in time. And that's going to give our 10-year time lock to this contract, not allowing us to take any funds away from the contract until 10 years has elapsed. The reason this is relevant, and you'll see this in a lot of different use cases, specifically you might see time locks inside of maybe, say you join a DAO. We've not talked about DAOs much on this channel, but say you join a DAO, and inside of this DAO it says, it's kind of like joining a company with equity. So you join this DAO and they give you a certain amount of equity. So say they give you 100 tokens inside of this DAO, and it's a 4-year distribution. So over 4 years, so say year 1, 2, 3, 4, etc., you'll get 25 for each year. So this is kind of like a cliff distribution of those tokens based off of the DAO you've joined. And this is similar to, this is one use case for using the time lock. Another use case you might see is for NFTs, where you have an NFT that you've purchased an NFT, but instead of just buying the NFT and then reselling it on the secondary market, what they might do is they say, you purchased the NFT because you believe in the community and you believe in the kind of the virtual world that we're building together. They'll say that you purchased this and you're unable to actually sell it for 3 years. Now, with that being stated, when doing research into time locks, and specifically how to avoid the lock mechanism on yourself, I've seen some attacks where, say you've purchased an NFT, instead of selling the NFT directly within the 3 years, say that they've limited your, you're not allowed to sell it for 3 years, what you can do is you can sell the rights to selling the NFT in 3 years. And it's kind of like selling options in the traditional kind of financial and trading space. So you can basically sell your option to sell this to another individual. So say this is person 1 and this is person 2, then they'll have the rights to sell this in 3 years whenever you sell it to them. So you probably will sell it to them at a discount, because this value might be like 1,000. You'll sell it to them for 900 or maybe even 500. And then when you do that, that's going to allow them to make a profit in 1,000 in a couple of years. So that's two use cases of how time locks come into play. So another state variable that's being set here is the initial supply. So this isn't really having any values derived in it yet. So this is just uint 256, and this is uint 256 as well. They actually didn't specify that, and that's a bad practice. You would actually want to have that be specified as 256. Address here, we're going to have our player, and that's going to be us. So we have our state variables. Now we're going to go into our constructor. So when running your constructor, specifically when you're inheriting from another contract, you can actually utilize their constructors as well. So you can see that the ERC20 constructor that we're going to inherit from here is going to do two things. It's going to set the name of the coin, and it's also going to set the symbol of the coin. So our symbol is going to be 0x0, and you can see that being called out here in this comment. So you can see the symbol is going to be 0x0, the name is going to be not coin. And I'll show you specifically in the ERC20 documentation specs in a second how I know this and why I found this out. And then in our constructor, we're also going to set an address as a player. So that's going to be our input variable for when this is deployed. And then we're going to have a few items in here when this is being constructed. So the player is going to be labeled as the variable as player. So that's going to take over this state variable here. Down here, our initial supply is going to be basically this number times this number. And now decimals is the one that I mentioned up here that this comment is kind of not necessary, but is, in the sense that this decimal is going to be 18 decimals is what is provided, and this is inside of the specs, so I'll show you that as well in the specs. So we're going to take this times by uint to 256, or typecast it to that, times by 10, and then times by this, and that's going to give you your initial supply, which is a really large number. And then in addition to that, once we've gone through this process, we're going to mint that I guess value, that money, and that mint is then going to be applied to this player. And it's not applied to it yet, but I think it's basically saying that this player is going to mint this total supply, and then this emit transfer. So this is an emission of an event. It's going to transfer from the the kind of the deployed contract address you can see zeroed out, they're going to transfer it from this address to this address, and they're going to transfer this amount of money to that address. Hope that kind of makes sense. One point about the emission is that this is just a way to emit events when contracts are deployed or things happen within the execution of a contract. And this is useful for a lot of off-chain applications that are looking for these items that have been indexed or emitted into the logs that you can then show interesting trends or make use of these events in other applications. So after knowing all of this, we can see that we, the player, this is referring to us, have an initial supply. So we have a bunch of money already. We just need to be able to figure out a way to siphon off all that money and get our value down to 0 so we can then pass this level. So we can see a function here that's stated as transfer. So this transfer function is basically stating that we want to transfer to this address this amount of value. We're going to override. Oh, we're saying this can be overridden. Okay, so it's override public lock tokens returns. So this modifier is being mentioned down here, which we'll touch on in a second. It returns a Boolean and has a transfer to value, etc. So what we're going to do is we're going to call super, and this super is referring to the ERC20 we've inherited. So when you inherit a contract, you can call super on that, and you're going to call the method in that contract that you've inherited. So transfer is a method inside of ERC20 that we're calling here, and we're going to say we want to transfer to this address, which we stated here, and we want to transfer that amount of value to that. If this is successful or fails, we'll get a returned Boolean on that, saying false or true. And this is a note that I added here, just to remind myself. All right, so once we've done that, I want to call it the modifier that we just mentioned. So we have a modifier here that's going to basically leverage our time lock, the one that I mentioned here. So this is basically saying that, all right, if the sender is the player, which is us, that's true. That's good. And the requirement is that the block timestamp is greater than 10 years. So this is basically saying that our 10 years has elapsed and we're allowed to send it because it's over top of the time lock of the 10 years. Then you can actually transfer. So this is going to allow you to actually transfer. This is good. Else, if this is false, then we're not going to allow it to happen. And we're going to continue through the overall contract and provide back a false, and that's a no. And that's what's happening with that modifier. So with that being said, that's what the target's kind of encompassed, and we should walk through the specs now so you can kind of get an understanding of why and how I found out a lot of this information. So we'll go to the notes first. So when first reading through the target and looking through the solutions, the first question I asked myself is, I understand inheritance and the concept of other languages, but how is it applied within smart contracts? So I came to this link first, which does a pretty good job at explaining kind of what Solidity, how Solidity uses inheritance and how that applies to contracts, and they give you a few examples, which is nice. So this is definitely a good place to kind of start learning about inheritance within Solidity. Another item here is going to be the tech specs. So before I jump into that, we're going to look at this kind of simplified graph to understand what inheritance looks like inside of Solidity. It looks like basically anywhere else, honestly. So in example here, we have contract A, B, C, D. So contract A, if it doesn't inherit anything, it's just going to be contract A like we've always seen, contract and name. If we're going to inherit contract A, it's going to be contract B is A. So that means we're inheriting A and all the methods that come along with that. Below that, you can see that if C inherited A, it would be similar to B. So we're basically one depth away from A, so we're going to have a similar structure here. And then below that, we're going to inherit D. So contract D is A, B, and C. So D is actually inheriting not only A, but it's going to inherit C and B. So we're inheriting multiple contracts in here. And you can see that the way that they've structured this, the way that these are ordered actually matters. So what you want to do is you want to ensure that the base layer of the contracts you're inheriting is first, and then you can, since these are the same depth, the ordering doesn't really matter here. So you can put B and C next to each other, but you always want to make sure that the first item that's being inherited, the very base layer, is placed first, the second is second, third is third, etc. So that order actually matters when doing this. So that's kind of a high level what inheritance looks like within inside of the syntax of Solidity. And then we're inheriting ERC20, which is what I've linked here, but let me read my notes really quick. Okay, so this point here is hinting at what we're going to talk about in the specs in a second. So you can see that what I mentioned here is that we're inheriting not only the mandatory methods from ERC20, but there also are actually optional methods inside of ERC20 that are optional, but if you don't necessarily take into consideration the mandatory methods that you're pulling in, that can lead to issues. So let's go to the specs and see what that looks like, which I already have pulled up here. All right, this is zoomed in quite a bit. All right, the simple summary, this is a standard interface for tokens. It walks you through the abstract, the motivations, etc. But right below that's the specifications for the token. And we can see it jumps right into the methods down here, so starting with name. And you can see that some of these are optional. And I've taken a quick screenshot and highlighted those here. So there's really 3 optional methods. So there's name, symbol, and decimal, and those are all that we've mentioned inside a constructor. So remember how we talked about the constructor here, where we were establishing the name, the symbol, and then the decimal here. Those all are optional methods. So they're not necessarily mandatory, but they're useful from time to time. So people will use those when they're kind of inheriting ERC20s. And then below that, below those, everything else is mandatory. All of those methods are going to be inherited whether you like it or not. So you have to do something with those methods. If not, then they can be potentially maliciously used against you. And with all that being stated, most contracts are inheriting ERC20 from safer implementations, which is the Open Zeppelin implementation that we discussed a second ago, and that's linked here. So this Open Zeppelin implementation, so if we go to tokens, ERC20, and then the Sol file, you can see in here they've added a bunch of context and documentation and comments explaining exactly how they're interpreting ERC20 and how they're implementing it, and the reason why they're implementing the way they're implementing it to make it a little safer. And here they've considered all the mandatory as well as optional methods within ERC20. So this is probably one of the better methods of actually going about kind of inheriting ERC20 is through a safer implementation like Open Zeppelin's. One thing I'll point out here quickly is that you can see down here that the decimals thing that I mentioned previously, you can see it's returning 18. And that's kind of how I knew that I would come back with 18 there. All right, so that is stated there. Within the contract, you can see some of the items here. So there's total supply, and it explains what that is, the balance of, transfer, transfer from, approve, etc. Now, the thing that matters to us here, and what we're going to take advantage of, are these 3 items. So we have transfer, we have transfer from, and approve. So when we looked at our contract, remember that it had transfer there. So transfer existed. And just to remind you, let's jump back and look at it really quick. So we can see here, we have the transfer methods being called out. So we're explicitly stating transfer, and we're utilizing that mandatory method, but we're ignoring the transfer from and approve. Now, within ERC20, there's 2 ways you can transfer funds. One of which is the one that we've considered, and then the other one is utilizing these 2 in accordance to each other. So when using transfer from and approve, you have to use them kind of together. So first you have to use approve, and that's basically saying that you're allowing a certain spender to withdraw a certain amount from your contract that you care about. And then transfer from is followed after approve, saying I would like to transfer, from this address to this address this certain amount. And if those aren't explicitly mentioned and considered within our contract, that is going to be the loophole that we're going to leverage to actually get around the time lock. So instead of utilizing the transfer, which is specifically called out inside of here, which has the modifier labeled on top of it, if we're not using that then this modifier and this method no longer matter to us. So we can actually instead use transfer from and approve, bypass the lock time, and actually siphon off all the funds pretty simply. And another way that you can see that these have not been considered, there's 2 ways you can do this. One of which I did first was remix. So I just came in here, I made the edits that I mentioned previously with the time block stamp and the 8.0, etc. If you save this and you deploy it, so let's go to Naught coin and we'll deploy it to, we'll deploy it to the contract address here. So this is going to be our address. Make sure this is, yeah, cool. So I'm going to deploy this so I can show you the 2 ways of how you can see that there are mandatory functions that are mandatory methods that are not considered inside of this implementation. All right, so this is deployed. So if we go down here and expand this, you can see that there are tons of options here, right? And all these options are not reflected in the contract that we see. A lot of those are coming directly from what we inherited via ERC20. So for instance, we see approve here. That's not mentioned here. We see transfer from here. That's not mentioned here. Some of these other items are mentioned here, so we can see the name of it is Naught coin, the initial supply is that big number I mentioned, decimals is 18 like I mentioned previously, player is going to be the player that we've input, so that's going to be the contract address just for this deployment. That's a symbol. The time lock is 10 years, and that's in, I don't know what value that is in. And then total supply is going to reflect the initial supply. So these are all items that we've seen, but a few of these don't exist in here. So we can actually leverage those ones that don't exist. Another way of seeing that is doing the traditional thing that we've done time and time again with all of these levels, and just looked at the API via the contract. And if you look at the API, you can see that there's tons of mentions of functions and methods that aren't being considered within the actual code snippet that we're looking at, and these are things that we can take advantage of. So with all that being stated, we're going to go back to the notes and make sure I didn't miss anything. All right, so we talked about ERC20. Real quick point here, I wanted to just call out, there's a lot of ERC20 based tokens. Most tokens, not most, I'd say the good majority of tokens in Ethereum are based on ERC20. It's a pretty prevalent kind of foundation that other coins build on top of. And here's just a simple graph to show you some popular ones that you probably know have heard of. Another link here is based on Etherscan, so you can filter it down by ERC20 tokens, and then they rank them based off of, I think, market cap maybe? Probably market cap. So you can do Tether, Binance, USD coin, another Binance one, Wrap UST, Shiba Inu, all that stuff. All these are, and even Matic, these are all based on ERC20 specifications. And obviously they built a lot on top of those. So it's a pretty prevalent specification. So it doesn't mean that it's completely unsafe. It just means that if done incorrectly, it is unsafe. This is me showing you the link to Open Zeppelin. So if you wanted to implement this, I'd recommend considering this one instead of just the base ERC20 specs, doing it from scratch. Here's a good article that I read that walks you through specifically why implementing this incorrectly is an issue. They've walked through a specific type of attack, not the one that we're doing right now, but it shows you another way that this ERTC implementation can be impacted. So it's an interesting write-up that you may or may not be interested in. All right, did this. Cool. Okay, so basically I'm just saying here, reflecting what was mentioned in the article that I just mentioned that I just said you should read, is that if there is, if the methods that you've inherited from ERC20 are not being utilized, then you should still explicitly state those and put them out there, but also you should throw an exception, an error that should be thrown when somebody utilizes it, not allowing them to do any transfers via that method. So that was just one kind of takeaway from the article that I pointed out here that I thought was kind of useful. And this is a note that I'll explain in a second. Just I had to do some additional research about run some stuff that I'll explain to you, which is about JavaScript and things like that. All right, cool. So first things first is we're going to figure out who the player is. So if we type in player, which is basically we're calling the state variable that's been publicly disclosed, so it's a getter that we can get as free. And we're going to figure out what this address is and what the initial address here is set. And we can see that we are the initial address because if we go to our MetaMask, we can see that this is matching our account. So that's good. We know that we're the player, so we have a bunch of funds, or should have a bunch of funds. So if we do balance of player, then we get a response that has a whole bunch of money in it, or we have a bunch of not coins, right? And the reason we can call balance of is, once again, this is not called out in this contract, but it is called out in the ABI here. So you can see the balance of is being inherited from ERC20, which was in the spec that we just mentioned. And if you go up to the spec here and we type in balance of, you can see that you can call the balance of, and you just put in the owner of that, and then it returns the balance of that person, or that contract. So here we have a bunch of money here. One thing that our handy dandy friend, the blockchain web developer person that we cheated off of, the way that they actually went about this, and I don't 100% understand why this is needed. So if you know, please let me know. So if we do, we want to convert this word array into a string that's understandable. So if you do this, we're going to get an object promise that does nothing. It's not going to give us back an answer. So instead, our friend on the video did this, where he put the parentheses around the function and then called the toString. So what this is called, and I thought I linked the notes here, but maybe I didn't. That's a shame, because I definitely read through a lot of notes. So we will quickly immediate here. use of immediate functions. All right, so this, what we're looking at is called an immediate function. So this is immediate function inside of JavaScript. So there's an article that I will find here that I found useful. All right, so this one is another good explanation that walks you through what immediate invoked functions are, and that's what we were just referring to, is when they basically wrap the function with parentheses, and that function is then immediately invoked. So let's actually save this so I don't lose it, and I can share it with you later on when I edit the video. So we'll just do that. Cool. All right, so check this article out and understand kind of how and why immediately invoked in functions are utilized, and kind of how they're used and what the syntax is and all that stuff, because that's exactly what we're doing inside of the console here to get back a string that shows the value that that gives us an idea of how much funding we as a player have and how much funding we have to siphon off of this. So after we've done that, another thing that we'll want to look at is, I think it's allowance. And that gives us an error because we need to look back at the ABI. All right, so with allowance, we have two inputs. We have two addresses, which are going to be both us. This usually isn't the case. Usually it's going to be you and somebody else. But the reason we're doing this is basically we want to check to see if the player is allowed to transfer funds. And not just if, but how much funds this player can transfer. And we can see currently that the owner of the funds, which is us, and we're time locked based off the modifier we discussed. And then we're going to check to see how much we're allowed to transfer. It says that currently we're allowed to transfer no funds. And this allowance, if we go to the specs, it'll explain, it'll explain specifically what this is referring to, and returns the amount of the spend, blah, blah, blah. So this is referring to above the approve piece. So as soon as you approve somebody to spend funds, then their allowance is going to increase. Then you can call the transfer from here method. So if we go here, here, and we adjust this, so what we're going to do now is we're going to approve this player to allow them to spend this amount of money. Let's make sure this is correct, internet. We want to go to our ABI again, and we want to go approve input. So we're going to say the address that we're going to allow to spend the money, and we're going to say the amount that they can spend, which is what we have here. So this should work. Cool. So we're going to have to confirm this. And if the ABI doesn't make sense while this is doing its thing, if the inputs here don't make sense, like you need to put an address and then a uint, if that doesn't really necessarily make sense, then I would recommend going here to the approved specs and just reading through here and kind of getting a gist of what's being explained and why they're doing what they're doing. So that's kind of intuitive, similar to this. So now that we've approved this, we can run the allowance again, and we can see that that's changed. We've gone from allowing them 0 to allowing the entire supply to be transferred by this player now. So if that's the case, then we can actually transfer this. And then let's go back to our ABI and see specifically what the inputs are for transfer from. There's 3 inputs, so we're going to transfer from this address to this address for this amount. Now, what you need to do here is you want to get just a bogus address from Etherscan. So you can get any address you can transfer it to get off all the funds you want to get off. So what I've done is I've just gone to Etherscan, grabbed a random address from here. And what we're going to do is we're going to go back here, and we're going to do transfer from. We're going to transfer from player, which is us. We're going to transfer to the random address that we've grabbed. And then we're going to transfer the full amount. So we're going to transfer all this monies to that address because we like strangers, apparently. So we're going to confirm that. And you can see there's 2 ways we can check that this worked. Once it's validated, we can first close that tab because we don't need it. We can check the contract we sent it to, right? So if I refresh this, and actually probably have to wait for this to be confirmed. Okay, so it was confirmed. Let's do it one more time because I did it how many ever? Okay, here. Yeah, cool. So you can see that an hour and 23 minutes ago, I successfully beat the challenge. And then now I'm teaching you on the video 12 seconds ago how this worked. So we're transferring from our address here. We're transferring to this address, which is referring to the address we just copied and pasted from here. And we're going to transfer the entire value of 1,000,000 Naught coins. You can see the token that we're transferring is here, and this is the symbol for that token. And we've transferred all the funds to the contract. That's one way of checking it. You can check an Etherscan. Another way of checking is if we go to the same similar query that we did last time, where we do balance of, and we'll do the balance of the player, and you can see that our balance is now 0. Because if we go back up here, balance of, you can see we did a balance of earlier, and the balance of was a lot larger, and we can see the balance of here, the same thing, so it's the entire initial supply, and now it's 0. So from doing that, we know that we beat the challenge, because we've basically siphoned off all the funds from what it was to 0. This was a bit longer, but I hope that it was useful. We'll wait for this to do its thing, and then once it does its thing, then we'll say that we won. Ta-da! Congratulations! We did it. You can see, not coin, level completed, and then it walks you through some explanations of why this is the case and how when you implement a contract, you should implement it correctly and ensure that you explicitly understand and mitigate all the issues that come with mandatory methods that are inherited from the contract you're building on top of. With that being stated, that is not coin, and I will see you on level 16, which is preservation.